Problem number 5, it says for the network shown in figure, the switch is open for a long time and closes at t equals to 0. Determine Vc of t. So we need to find Vc of t. The diagram given is 1400 volts, 500 ohms, 200 ohms, 50 microfarads. This is the position of the switch. The switch is open for a long time, so we can start with the solution at t equals to 0 minus. This switch is open, so I can redraw the circuit. This will be open because the voltage will be developing across the capacitor, so we can calculate Vc of t at this instant, and t is 0 minus, so I can say Vc of 0 minus will be 1400 volts. The same will continue at t equals to 0 plus. The switch is just closed, so this will be the situation. The switch is just closed and here you have the voltage of 1400 volts. This is 200 ohms, 500 and 1400. So Vc at 0 plus will again be the same, is 1400 volts. Now we can say for t greater than 0, the switch will be closed, so we'll have resistance, then the capacitor, and then the voltage source. So this is 50 microfarad, 1400 volts, 200 ohms, 500 ohms, 1400 volts. So now applying KCL at this point, you'll get 50 into 10 raised to minus 6 dVc by dt plus Vc upon 200, this is voltage Vc, plus Vc minus 1400 upon 500 equals to 0. So dVc by dt plus 140 into Vc is equal to 56,000. So from this we can say P is 140 and Q is 56,000. So I can find Vc of t, which is Q by P. So 56,000 upon 140 plus C e raised to minus P into t. So I need to find C. So I can say at t equals to 0 plus, Vc of 0 plus, we have 1400. Substitute 2 in 1 at t equals to 0. So this will be 1400 is equal to 56,000 upon 140 plus C. So from here you can get C as 1000. Now I'll substitute 3 in 1, so I'll get Vc of t as 400 plus 1000 e raised to minus 140 t for t greater than 0. So this is how I got the equation for Vc of t.